talking through this spell work. So on the first one on the left, what is my index? Index of 2. So I'm going to split this up into multiple radicals. So I'm going to have plus or minus the square root of 225 times the square root of a to the 16th times the square root of b to the 36. Square root of 225, is this a perfect square or not? It's a perfect square. It is what times itself? 15 times itself. So plus or minus the square root of 15 times 15. So this is plus or minus 15. And then how do I do these next two pieces? Divide them by the index. So I have 16 divided by 2, which would give me what? A to the 8th. And b to the power of 36 divided by our index of 2. 36 divided by 2 is what? 18. B to the 18. And what is our index on the second problem? 3. Here's the index. So I have a to the 12 divided by my index of 3, which is going to be a to what power? A to the 4th power. Yes. Perfect. We're going to take notes in your book today, and we are going to have time towards the end of class for you to begin working on the homework. Problems 1, 2, and 3 on the homework. I went ahead and put those at your desk here. Problems 1, 2, and 3 on the homework go along with today's lesson. Problems 4, I think it's 4 and 5. Yeah, 4 and 5 go with tomorrow's lesson. Today we are going to focus on how to graph a square root function. How to graph a square root function. So this is the parent. We're on page 323. So when we're graphing a square root function, what types of numbers can I not have underneath a square root? My calculator can't do them. What types of numbers? What'd you say? I can have a 3 underneath my square root. It comes out as a decimal. I can't have a negative underneath my square root. So this number underneath the square root, this piece right here, must be greater than or equal to 0. So I say x is greater than or equal to 0. When I go to make a table to figure out where to plot my points, this number right here is going to be the first thing on my x side. Now, if I have something underneath the radical other than just x, I'm going to have to take that and make it greater than or equal to 0, and then I'm going to have to solve for x to figure out what the first number in my table should be. So in my table here, I start with 0, and then I'm going to try some other numbers after that. You're going to need a calculator today. If you don't have one in front of you, go ahead and grab and borrow one of my yellow calculators. If you need one, take one and pass it back to the table behind you. If you need a calculator, feel free to grab one. I want to make sure that pass it down there too. There we go. I want to make sure that we not only know how to type these things into the calculator, but we know how to make it give us the decimal approximation on these things. So first thing I want to do is square root of 0. Did you grab a yellow calculator, dear? All right. Make sure that stays put away for me. Thank you, Ibrahim. Does everybody know where the square root button is on the yellow calculators?
You got to press second and then the X squared.
Yes, you have to push second, so you have to start off by pushing that green button, and then you push the x squared key. It should make a square root show up on your screen. I want you to do the square root of 0. So after you see the square root symbol on your screen, we're going to type in 0 and tell me what you get. 0. Can I try numbers smaller than 0? No, why not?
It can't be negative.
Yeah, can't have any negatives. I need what's underneath here to be greater than or equal to 0. So give me some bigger numbers that we can do. 2, can I do 1? Yeah, let's just kind of walk through. So 1, 2, 3, 4. Could I keep going? Yeah, but if I get that many points plotted, I'm going to be able to begin to see this shape. So what happens when I put the square root of 1 in? Because I'm taking whatever's on the x side and I'm substituting it into this function rule right here for x. Square root of 1 is 1. So far I have a point right here and a point right here. Now if you do square root of 2 on your calculator, what happens? It says square root of 2, right? We want it to give us a decimal. We don't want it to give us just what it popped or what we put into it. So square root of 2, we're going to hit enter. And then just above the enter key, do you guys see that there's another white key that looks like it has arrows pointing to the left and to the right? After you hit enter and it gives you the answer of square root of 2, where you're like, that's nice, that's exactly what I typed in. I want you to hit that arrow button. And it'll give us a decimal approximation then. 1.41. 1.4 is pretty close to 1.5, right? So when I come over here to my graph, 1 and almost halfway. So 1 and a little bit more. What about square root of 3? Put that into your calculator. This is another one where we're going to have to hit the back and forth arrow buttons. 1.73. So in between 1 and 2, right? Closer to 1 or closer to 2?
2.
Closer to 2. So when I come over to my graph, I'm going to put something in between 1 and 2, but I'm going to make it higher up this time, not quite as high as 2. And then I'm going to do square root of 4. What is the square root of 4? 2. That one is exactly 2. So now I go and put a point at 4, 2 right here. We would trace through these points, but I only have an arrow pointing off to the right. Why don't I have an arrow pointing off to the left? Can't go negative. My arrow says I could have continued going off that direction, but we said I can't have negative numbers. So I can't point to the left. It's only going to point to the right. Let's talk about our domain and range for this, and then we're going to go look at an example where it's not just the parent function, but we're going to be comparing our graphs to the parent function, so I want to know what this one looks like also. My domain, things that I am allowed to use for x. Did we have any restrictions on x, or were we allowed to use anything we wanted? No negatives. So what was the smallest number we were allowed to use? 0. So you can either say x is greater than or equal to 0, or if you want to write that in interval notation, that would be 0 to infinity. Both of those mean the exact same thing. It means my smallest number is 0, and we don't have a biggest value. What about the range? Am I looking at x's or y's for the range? Y's. So I can look at my table, I can look at the y side, or I can look at my graph over here. Did we have a smallest or a minimum y value?
0.
0. All of my y values were greater than or equal to 0. Or again, I can write that in interval notation. 0 was the smallest. It kept getting bigger and bigger and bigger. Why didn't I say from 0 to 2 right here? It could be bigger. I stopped my table there, but the table doesn't have to stop there. I just got enough points on my table so that I'd know where to plot my points at. So far, so good? All right, let's go look at a transformation of this, something that has a similar shape to the parent. It's still a square root function, but it has been transformed from the parent. We're looking at example number 2 now, which is still on page 323. I'm going to skip example number 1, and we're going to go right to example number 2. Is it still on 323? I think, sorry, it might be on page 324, and I have my page numbers wrong. Page 324?
Yeah.
Let me fix that. Page 324, there we go. All right. So the first thing I need to do you guys see this part underneath the square root? That has to be greater than or equal to 0. Must be greater than or equal to 0. So the first thing I do is I set up an inequality with whatever is underneath there. In this case, it was x plus 1. Whatever's underneath the radical, I make it greater than or equal to 0. And now I want to get x all alone. What do I need to do to this to get x all by itself? Subtract 1 from both sides. So I'm going to minus 1 from both sides. So x is greater than or equal to what? -1. This is where I start the table at. I'm going to start the table right there. So that's where the -1 on the x side came from. I know I can't get any smaller than that, so I picked out numbers that are bigger than that. Numbers like 0, 1, 2, 3, 4. And then what we're going to do, we're going to type this into your calculator. So I'm going back to this function rule right up here. I'm looking at the function rule for g of x. Do you guys see everything that comes after it? What's the first thing that comes after the equal sign? -3. So into my calculator, I have -3, square root button. What's the first thing we said we're putting in for x? -1. What comes after the x here? +1. Is there anything after the square root sign? +2. To get out from underneath the square root sign, you're going to have to use the arrow key, that little oval keypad. So first we're going to type in -3, then second and square root, -1 plus 1. Use the arrow key so that you can move over. Yep, you missed your arrow key there. So we're going to come over here. We're going to delete those last two things. And we're going to use the arrow key here. And then +2. Do you see how that part's not underneath? That's what you want.
Okay.
And hit enter. What do we get?
2.
Yes, just like that. Equals 2. This is our y value.
You do it again.
Okay, so you're going to type in what I have written in black there, -3, and then square root, so second. Nope, that's a squared key.
Oh, shoot.
Just hit delete. Yep, second. And now hit the x squared key. That'll make your square root button pop up. And then we're putting -1 in the place of x first. So -1 plus 1. Now use your arrow key to come over. Yep. And then do the +2 on the end. Yep, hit enter. There you go. All right. What is the next x value that we have in our table? 0. So I'm going to do this all over again, but this time I'm going to put 0 in the place of the x. So I'm going to type it into my calculator almost exactly the same. -3 and then the square root. I'm putting 0 in the place of the x. And then +1. Use those arrow keys so that the +2 is not underneath the square root. We do not want the +2 under the square root. If you can't figure out how to do that, please raise your hand. I'm happy to come around and show you how to do that piece. Practice typing it into your calculator. And when you hit enter, What you get, you've got to practice with this piece, honey. Just watching us do it isn't going to be the same. -1. What's the next value that we wanted to use for x? +1. So I'm going to go type it in my calculator just like I've done the previous two. So I have -3 and then square root 1 + 1. Use the arrow keys to come over and +2. If you type this in your calculator exactly as I have it written there and you're using one of my yellow calculators, it won't give you a decimal answer when you hit enter. How do you make it give you a decimal answer after you hit enter? Yep. Right above the enter key, there's those arrows that point left and right. You want to hit that button right after you hit enter, and it should give you the decimal value. Right. So here. Come down here. Now try it. Oh, it didn't like that. So what we're going to do, hit enter, enter, and now hit that key. There you go. Hit this button right here. There you go. All right, what are we getting? -2.24. So I'm looking at this graph. The first point, when we put -1 in the place of x, we got a +2 back out. So I had a point right here on my graph. 0, -1 is this point right down here on the graph. -2.2 is going to be in between what two whole numbers? -2 and -3. So right here, right underneath -2. Come on. Got a couple more that we want to put in. -3 square root of, what's the next thing we want to put in? It's the next thing from our table. 2. So underneath the radical, I have 2 + 1. And then outside of the radical is another +2. What do we get? -3.19. That's going to be in between what two whole numbers? In between -3 and -4, so right down here. Closer to the -3. Why did my 2 move over here? There's one more number that I want to put in the place of x. What is that number? 3. I want you guys to look at this with me, because I can see already from the table that they said it comes out with a whole number answer. Look underneath the radical. What do I have underneath the radical here? 3 + 1. What is 3 + 1? 4. Do you know the square root of 4? Is it a whole number? So my answer is going to come out to be a whole number. If what's underneath the radical simplifies to something that I don't know the square root of, it's not a whole number that I know off the top of my head, I'm probably going to get a decimal answer back. Go ahead and pop this one in your calculator. Let's get the last one up here. I want it out to 2 decimal places. They didn't give us that far. -4 even. So when x is +3, y is -4. And then we're going to trace through those points, starting from the first point on the table through where we stopped on the table, with only an arrow going out in that one direction, not where my table started. No arrow where the table starts, because we have to be greater than or equal to 0. What is the maximum on this whole graph? What's the highest it ever goes? 2. -1, 2 would be my maximum. The x part where it's the highest is -1. The y part where it's the highest is 2. What is my domain? All the things that I'm allowed to use for x. What'd you say? We go to positive infinity. Was there a smallest value? -1 was the smallest. My graph started at -1. My table started at -1. And then it continues on and on and on to the right. Or I could keep going with bigger and bigger and bigger x values. So my domain is x is greater than or equal to -1. And the range, is my graph above or below what we said was my maximum? Here's the maximum. Is the rest of the graph above or below that point? Below. So am I going to use a greater than or a less than if all the rest of the graph is below this point? Less than. If it sits above that first point, then I'm going to use a greater than. If it sits below that first point, then I have a less than or equal to. Less than or equal to what? What was that top y value? 2. Now I want to compare this to the parent. I'm going to try to use some verbal descriptions. They have their own way of writing out a verbal description. I'll show you what I'm looking for, because on the homework I'm asking you to compare and contrast. We have A, H, and K up here in this equation, things that are different from the parent. This first piece is A, that's different from the parent. Inside this radical is where I see the opposite of H. That shifted my parent function. And then back here we have K. I'm going to put the parent function back up on the screen so that we can compare and contrast. But what do you notice about this point compared to where that first point on the table was for the parent? Where was the first point on the table for the parent? Right here at the origin, it was at 0, 0. So comparing that to this one, parents at 0, 0 is this first point at 0, 0. We've shifted which way, left or right from the parent? We've shifted left how far? We shifted left 1 unit. Did we move up or down at all from the parent? Did we go up or did we go down? Up. How far? 2 units. Up 2 units. Where do you see what we could be using from the equation to say left 1 and up 2? Which of these numbers, A, H, or K, have we made use of? H. H is the opposite of what I see here. That's -1. That makes sense with left 1. And K, positive 2. We went up 2. Which value have we not talked at all about yet? The A. What kind of number is A? Negative. How did that affect my graph? Let's look at the parent one more time. Here's the parent. Goes up and over. How does this one go? This one scoops down. This one has been reflected over the x-axis. And there's one more thing that I see that has happened. This has been stretched. When I look at the parent, I'm going to go back and look at that one more time here. When I look at the parent, Do you see how it's moving up one and then it didn't even go up a whole unit until we get over here? With this one, I moved down 3. That's a much bigger stretch. If it was just like the parent, it would move down 1. And then it would take a little bit of time before it moves down 1 more. So this has been stretched vertically by 3. Vertically stretched by 3. I want to give you guys the rest of our class time to begin working on that homework assignment on the worksheet. Again, problems 1, 2, and 3. So you're going to need to draw a table. You're going to make your table the way we did here. We're going to take whatever is underneath the radical, make it greater than or equal to 0. Solve that for x. That tells you where to start your table. What'd you say? Leave this up? Absolutely, I can leave this up. And then you're going to need to use your calculator. You're going to substitute it in.
Do we draw the table where B is?
You can draw the table there, or you can draw it off to the side, wherever you want to put it in that spot. Yep. But after you get it graphed, then you'll need to tell me the domain and the range, and you'll need to use words to describe the transformation. So like we did down here, where it was shifted, left and up, reflected and stretched. That's what part D is asking for on each of these problems. So start off by making your table. I am here to offer help. I'll be moving around the room. I would love for everybody to get done with at least one of these, so that if you run into any problems, I am here to offer assistance.